Hello class 8 students, welcome everyone. So the next topic from the chapter force and pressure is pressure exerted by liquids and gases. So in the last video we have discussed about pressure, right? So what is pressure? Pressure is equal to force by area. Okay, the force acting on an object of a particular area or a unit area is called as pressure. Okay, so liquids and gases also exert pressure. In fact, all the liquids exert pressure on the base and walls of their containers. Okay, substances like water, oil, alcohol, petrol, mercury, etc., all the liquids exert pressure on the bottom and on the walls of their containers. Okay, so pressure is exerted by all the liquids, but since water is the most common liquid around us, so therefore we will be using water as the liquid in our activities. Here are some of the activities: activity 11.8, activity 11.9, 11.10. So in all these activities we will be using what? Water as the liquid. Okay, so yes, all the liquids have weight. So when we pour a liquid into a vessel, then the weight of the liquid pushes down on the base of the vessel or bottom of the vessel, producing a pressure. Okay, so we can say that the liquid exerts pressure on the base of the vessel in which it is kept. Clear? So the weight of this liquid pushes on the base of the vessel and exerts a pressure on the base of the vessel or bottom of the vessel. So the pressure exerted by a liquid is again given by the formula of pressure is equal to force by area. Clear? Okay, the weight of the liquid pushes on the base of the vessel and it exerts a pressure on the base of the vessel or bottom of the vessel. So the pressure exerted by a liquid is given by this formula. Okay, pressure is equal to force by area. Okay, clear? Yes. So you have to note that what the vessel in which the liquid is kept is also known as its container. Okay, it's simple as that. Now activity 11.8. Okay, activity 11.8 shows you that how a liquid exerts a pressure on the bottom of its container. Okay, how the liquid exerts pressure on the bottom of the container. So you have to take a transparent plastic pipe. Clear? You have to take a transparent plastic pipe like this. This is a transparent plastic pipe you have taken. It should be about, what is the length given to you? 15 centimeter. Okay, the length of the pipe or tube should be about 15 centimeter and its diameter should be 5 to 7.5 centimeter. Clear? Diameter should be 5 to 7.5 centimeter. Okay, also take a piece of thin sheet of a good quality rubber, say a rubber balloon. Okay, you have to also to take a rubber balloon, this one. Okay, you have to fix the rubber balloon on the one of the end of the tube or say pipe. Okay, stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle, keeping it in a vertical position. Ask one of your friends to pour some water in the pipe. And you have understood this line, that you have to fix this rubber on one of the end of the pipe and you have to hold this pipe vertically. Okay, then you have to ask one of your friend to pour some amount of water inside this pipe. Okay, just like this, it is shown over here. Okay, what will you observe? Does the rubber sheet bulge out? Okay, does the rubber sheet bulge out? Yes, the rubber sheet will bulge out. Why? Because see, the bulging out of the rubber sheet demonstrates what? This in the next figure you have seen, no? This one. This rubber sheet is bulging out. Okay, what it shows, it demonstrates that the water poured in pipe exerts a pressure on the bottom of its container. Which is the bottom of the container? What is the bottom of this pipe? This rubber sheet, right? The bottom of the pipe contains what? Rubber sheet. So this happens because the bottom of the container, or say pipe in this case, is made of a flexible thin rubber sheet which gets stretched by the pressure exerted by water to form a bulge. Okay, because the rubber sheet is flexible, right, and it has been placed, or it has been attached or fixed on one of the end of the pipe, where in the bottom of the pipe mainly. Okay, so when the liquid is poured, when the water is poured over here, then you will see the rubber sheet will bulge out. Clear? You have understood? Okay. Next, what is given? Note also the height of the water column in the pipe. Pour some more water. Okay, observe again the bulge in the rubber sheet and height of the water column in the pipe. Okay, so if you pour some more water in the plastic, in this pipe, then the height of the water column in the pipe will increase, right? We'll find that the height of water column increases in the pipe, as you can see here only. In the initially the water level was here, then after pouring some more amount of water, the water level is reached here. Okay, so the level of water, or the water column in the pipe, increases. Clear? It is showing what? It is showing that the pressure of water on the bottom of its container. What is the bottom of the container over here? This rubber sheet. Okay, the pressure of water on the bottom of its container has increased. Clear? So in fact, greater the height of water column in the pipe, if the water column in the pipe is greater, the height of the water column in the pipe is greater. If it is greater in the pipe, then there will be greater amount of bulge. Okay, greater will be the bulge in its rubber sheet bottom. Okay, which shows that greater pressure exerted by the water. So from this activity we can conclude that a liquid exerts pressure on the bottom of its container. Understood? Liquid exerts pressure. Okay, liquid exerts pressure. Where? It is acting pressure where? On the bottom. On the bottom of what? On the bottom of container. On the bottom of container. Okay, container. You can understand? Liquid exerts pressure on the bottom of the container. Okay, this is the first conclusion, and the second conclusion is what? That the pressure exerted by a liquid depends on the height of the liquid column. Okay, the pressure exerted by a liquid depends on what? It depends on the height of liquid column. Clear? So these are the two conclusions we can draw from this activity 11.8. okay, again I am repeating, what is the conclusion? That a liquid exerts pressure on the bottom of its container, and the pressure exerted by a liquid depends on the height of the liquid column. Clear? Next activity 11.9 we'll see now here. Yes, activity 11.9. So in this activity is used to demonstrate that a liquid exerts pressure on the walls of its container or sides of its container. So you have to take a plastic bottle over here. You have to take a plastic bottle just like this. Okay, this is the plastic bottle. So you have to take a plastic bottle like say a water bottle or any other soft drink bottle. Then you have to fix a small glass tube. You have to fix a small glass tube a little above the bottom of the plastic bottle, just like this. You have to fix a small glass tube just above the bottom of the plastic bottle. Okay, here. So we can do this by heating one end of the glass tube slightly over a burner and then inserting a hot end quickly into the wall of the plastic bottle. So we should seal, okay, we should seal the joint of the glass tube, this glass tube. with a plastic bottle by using a molten wax, so that water does not leak from the joint. Okay, water should not leak from the joint. You have to keep that in mind. Clear? Okay, then you have to also tie a thin rubber sheet, like say from a rubber balloon. You have to tie a rubber sheet, this one. Okay. Okay, now you have to fill half of the plastic bottle with water. You have to fill half of the plastic bottle with water, just like that. More than half of the plastic bottle with water. Okay, what will we observe then? We will observe that on filling water, the rubber sheet tied to the mouth of the glass tube gets stretched. Here, it will get stretched. Okay, and it will bulge out. Okay, so the bulging out of the rubber sheet tied to the glass tube fixed in this wall of the plastic bottle demonstrates what? It demonstrates that the water present in plastic bottle exerts pressure on the wall of the bottle. Water present on the plastic bottle exerts pressure on the walls of the plastic bottle. Okay, it exerts pressure on the walls of the plastic bottle, or say side of the bottle. Okay, so it is the sideways pressure exerted by water which will inflate the thin rubber sheet of balloon. Okay, it is due to the pressure exerted by the water which will inflate the thin rubber sheet and form a bulge. Okay, and if we pour more water in the plastic bottle to increase its depth, if we increase the water level, if we go on pouring some more water over here, then what will happen? We'll see that the bulging in the rubber sheet increases. Okay, it will increase. The bulging in the rubber will increase. So this indicates that the pressure exerted by water increases with increasing depth. Okay, so and again from this activity we can conclude that a liquid exerts pressure on the walls of its container, and the pressure exerted by a liquid on the walls or sides of its container increases with increasing depth. Clear? I am repeating it to you that a liquid exerts pressure on the walls of its container, and the pressure exerted by a liquid on the walls or sides of its container increases with increasing depth. Clear? Okay. So what is written over here? You see, note that the rubber sheet has been fixed on the side of the container and not at the bottom. Does the bulging of the rubber sheet in this case indicate that water exerts pressure on the sides of the container as well? Yes, water exerts pressure on the walls, or we can say water exerts pressure on the sides of its container. Okay, and the pressure exerted by a liquid on the walls or sides of its container increases with increasing depth. So these are the two conclusions we can draw from this activity 11.9. Now last activity is there, activity 11.10, which shows you that how a liquid exerts pressure, or how a liquid exerts equal pressure at the same depth. How a liquid exerts equal pressure at the same depth. Okay, so again you have to take a plastic bottle over here. This one is the plastic bottle. Okay, now you have to make small holes. You have to make how many holes are shown over here? This one 1, 2, 3, and on the other side 4. So you have to make 4 holes. Okay, you have to make 4 small holes of equal size on the plastic bottle at the same distance. Okay, at the same distance above the bottom of the bottle, at the same distance above the bottle of the bottom. Okay, at the same distance, the distance of the holes should be same from the bottom. Clear? The distance of the holes should be same from the bottom of the bottle. Okay, so the holes should be, and the holes should also be exactly at the same height from the bottom of the plastic bottle. Now you have to fill the bottle with water, and we will observe that the 4 jets of water will be coming out from the 4 holes and will fall at the same distance away from the base of the bottle on its either side. Okay, just like this. It will fall from the same height. The water jets will fall. Okay, we'll observe that the 4 jets of water will be coming out from the 4 holes, and it will fall at the same distance. It will fall what? At the same distance away from the base of the bottle. Okay, so the 4 jets of water can fall at equal distance on the sides of the bottle, and this happens only if the pressure of water at the depth of the holes in the bottle is equal. So from this activity also we can conclude that a liquid exerts pressure on the walls or sides of its container, and a liquid exerts equal pressure at the same depth. Okay, a liquid exerts pressure on the walls of its container, and a liquid exerts equal pressure at the same depth. Clear? So these are the two conclusions we can draw from this activity 11.10. Clear? So can you now say that liquid exerts pressure on the walls of the container? Yes, we can say. And do gases also exert pressure? Yes, actually gases also exert pressure. Okay, so do they also exert pressure on the walls of their containers? Yes, just like take the example of a balloon. If we inflate a balloon using means if we blow air inside the balloon, then it will get inflated, and the air inside the balloon exerts pressure on the walls of the balloon. Okay, so what is written here, you see, when you inflate a balloon, why do you have to close its mouth? Why? Otherwise the air will get out of the mouth from the balloon, right? So we have to close the mouth of the balloon. Okay, so suppose what happens when you open the mouth of an inflated balloon? If we open the mouth of an inflated balloon, then the air will get out. Yes or no? The air will pass out from the balloon. Then are you getting it? So would you be able to inflate it? No. If not, why? So see, actually what happens when we put a lot of air in the balloon, okay, when we put a lot of air in the balloon, then the number of gas particles in the balloon increases too much. Okay, and the large number of gas particles cause too many collisions with the walls of the balloon from inside, and it will create a high air pressure. So due to this high air pressure produced by the gas particles on the walls of the balloon causes it to expand and get inflated. So if we'll open the mouth of an inflated balloon, then the air will get out from the inflated balloon, right? And it will not get inflated, right? So the air will get out. So the air will, if the air will get out, then ultimately it will not exert pressure on the walls of the balloon. Okay, so it will not be able to inflate it, right? So do you recall what happens to the air in the bicycle tube when it has a puncture? So do these observations suggest that air exerts pressure on the inner walls of an inflated balloon or a tube? Yes, air or say gases exert pressure on the walls of their container ultimately. Okay, so this is the conclusion we can draw from this, that pressure exerted by gases. Okay, that when the air is filled into a container, when air is filled into a container with say a balloon with our mouth, then the balloon gets inflated and it will get bigger in size. And when air is filled into a bicycle tube with a pump, when air is pumped into a bicycle tube by using a pump, then the bicycle tube inflated due to the air pressure exerted by the collisions of gas particles in air with the inner walls of the tube. So this air pressure in the bicycle tube makes the bicycle tire feel hard. So from these two examples we can draw the conclusion that when air is filled into a balloon with our mouth, the balloon gets inflated and gets bigger in size, and when air is filled into a bicycle tube with a pump, the tube gets inflated and makes the tire feel hard. Okay, so gases too exert pressure on the walls of their container. So this is the conclusion we can draw from pressure exerted by gases. So you have understood that the liquids and gases exert pressure exerted by liquids and gases. Okay, yes. So with this we will conclude this video today. Okay, our last topic is left from the chapter, that is atmospheric pressure, which we will be covering in the next video. Okay, so yes, that's all for today. Thank you and have a nice day.